Welcome back to this channel, and in this whole large language model flow we will first today understand tokenizer. We will understand that how a raw text is first tokenized and converted into the IDs. In this whole flow we will first try and understand the tokenizers, the different types of tokenizers, and the BPE tokenizer algorithm in details. So let's get started with the first part in understanding the tokenizers. GPT, LLaMA, Mistral. These giant models don't actually read the text the way we do. They read tokens. And those tokens are created using a surprisingly simple algorithm called BPE, or the Byte Pair Encoding. Let's take a simple example of Hello World, which can be broken down into simple tokens of HE, LLO, and World. So this tiny step that you have seen here is the secret to behind the understanding of large language models. But let's first understand that what actually is a tokenizer. A tokenizer can be said to be a bridge between the messy human language that we have and the clean integer world where transformers live, right? So you got like integers and then to the transformers algorithm. There are three types of tokenizers basically. Let's try and understand them first. Like the first one that we will consider is the word level tokenizer. So let's take for example a simple sentence like I love football, which can be broken down into I, love, and football. So it's okay, like you are breaking down a simple sentence into three different words. Now let's understand the second tokenizer that we have is basically the character level tokenizer. Now in character level tokenizer, if we consider the same sentence that we have, the I love football can be broken down into simple small characters that you see here. Like it's broken down into I, then L, then O, then V, then E, and so on till the sentence end. But the most important of these tokenizers is the subword level tokenizer, which we are going to discuss today, and we will try and understand that why it's preferred and is the best. But actually, why are we considering the subword level tokenizer and not the word level tokenizer? Let's try and understand the disadvantages of the word level and character level. So let's take for example a very rare word like football lyceus, right? Like if you consider in a word level tokenizer, this is a very rare word and it cannot be broken down using the word level tokenizers, right? If you consider the character level tokenizer for the same word like the football lyceus, it's going to be very long, right? And now for the subword level, let's take for the subword level. The subword level enjoys a sweet spot, like as rare word like football lyceus can be easily broken up into. You can see that here, right? Using the subword level. That's why we are considering today to understanding of the byte pair encoding tokenizer, which is actually a subword level tokenizer. Uh, Now let's go into the other part. Now, for understanding the last part, that is the byte pair encoding, let's first understand the concept of bits and bytes. We take this sample text here, right, as you can see. Now, we can convert this into a byte array, and when we call the list operation on it, you can see here, like we are converting this into a byte array here, right? And then when you call upon this list on top of the byte array, we can see that uh, it's basically converting this particular text into a list of integers, right? Now this can be considered like a valid way to convert like text to IDs, that what we are trying to do here, right? Understand, right, for large language models. But for example, in case of GPT 3.5, you can see here, let's just zoom in here, right? Look at the token count here. What I'm trying to suggest here, it's just 6 in here. Like if you look at the token count, like for this is a sample text, the length was 21, and consequently when we converted it into a byte array and then into the integers, we can see that the length is again 21 here, right?
This is not the case in for the model of GPT 3.5 Turbo, right? You can see it's just 6. Now, if you consider again for GPT-2, it's just 5 here, right? Just 5. Similarly, if you consider for like model GPT-4o, it's just 5 again, right? So these large language models use the library of TikToken, and I will attach the interactive UI in the description so that you guys can also go and explore for the different models and different types of tokenizers there. Okay. Now the other part, let's try and understand is that concept about byte. Now we all know that a byte consists of 8 bits, right? So let's say here you have got 8 bits here, and so there are 2 to the power of 8, like is equal to 256 values basically that a single byte can have. Like if you want to see that, you can confirm, like if you do from byte array from 0 to 257, which is basically 2 from 0 to 255, if you do, you will get the list. But the moment you do from 0 to 256, you will get an basically an issue or an error. A byte must be in the range of 0 to 256 here, you can see. Similarly, when we do from 0 to 255, we get it. Now, what I'm trying to suggest here is that that in a byte pair tokenizer or a byte pair encoding tokenizer basically uses these 256 values as its first like single character tokens, like you can see here, right? Like this is 16, like you can imagine it like this, like you have got 16 here and a 16 here, like a grid, right? If you want to make it much more clear, and for each id, like from 0 there might be a token assigned as this, 1 might be a, and so on till 255 single character tokens. Please stress that. Okay, we can basically inspect this by using the TikToken library also. Like if you see, if you import the TikToken library, right, and if you get the encoding for GPT-2, and if you do a range in 300 from till 255, if you notice, you will see the single character tokens here, right? Here you can see the single character tokens. After 255, you will observe the dual character tokens, like 2 characters. This is basically space and T. This is again space and A. This is HE, right? This is N, and so on. Great. So you can observe that these are double characters here. Now let's understand the primary objective of BPE. Now the primary objective of basically BPE is to build a vocabulary, like at 258, if you observe here, like at 258 you have HE, right? So using HE you can always make words like the, heap, heal, right? So you can observe that the primary objective of basically BPE algorithm is to make a vocab list of these kind of tokens which can be used to construct bigger words, right? As a matter of fact, also, like BP was introduced in 1994. I will attach the main paper link in the description and you can go through it. Now let's understand the BPE algorithm. Uh, just a minute. So this is the BPE algorithm, right? And we will go through the BPE algorithm and understand it with the help of an example. Like if you observe, the BPE algorithm basically states that we first find the frequent pairs, and then in each iteration, like while finding the frequent pairs, we scan the text to find the most commonly occurring characters. Like we replace and record and then replace that pair with a new placeholder like a ID, which is not basically in the vocab, so we can assign it with 256, right. And then as the vocab grows, we also check that if there are any frequent pairs left or not. If yes, we continue with the algorithm, otherwise we end the loop. Let's understand this with an example. Let's take an example of this sentence: the cat in the hat. Observe, th is basically repeated, right? So let's keep it at like the 256 as th, right, since 256 is not in the vocab. Now we replace and keep it in a lookup table, right? So now the new text you can observe is this, right, with the token id and the cat in the again the new token id in the hat. We then update the vocab, and then the updated vocab will basically look like this. You can observe that. Then the second iteration, again, like you can see the updated text here, right? And we replace that token with a new ID, right? Let's say, for example, we replace it with 257, right? So the updated text will have the new ID, which is 257, cat in the 257, basically the token ID hat. We then again update the vocab. You can observe here, right? And in the iteration 3, you can observe that this particular token ID, like the 257 space ID, is appearing twice. So it will again replace with a new token ID, okay, because this has been repeated. So let's replace it with, let's say, 258. So now the updated text will basically look like this, like 258 cat in the 258 hat, like basically the token ID. So now you have the updated vocab, and you can observe that the updated vocab has got the token IDs against basically the the characters or the frequent characters clubbed together that we are observing. So basically we will continue this loop that until we are done, like until there's no frequent pairs left in the whole sentence, or we have replaced each of the character with a token ID, right? Similarly, like what we have gone through in the algorithm, we can get back the original text also by back substitution. Okay, so this was the whole video about like tokenizers, understanding the subword, importance of subword tokenizers, and the BPE algorithm. Hope you like this video. If you like this video, please like and subscribe. Thank you.